we'll pick up from where we were left. We're still looking at extracting labeled concepts, a set of instances that would belong to some class that is named, that is labeled. More recent work here is from Israel, from Indo Dagan's group, the main culprit being Vered Schwartz, one of the PhD students there. This paper received the Best Paper Award, I think, last year at the ACL conference. The title, it's suggestive, but at the same time, maybe suggests kind of the wrong thing. Of course, it's trying to integrate, so to merge, to combine two different things. The two different things are path-based and distributional. So one may at first wonder what that means exactly, path-based and distributional evidence. Well, what that means, the path-based evidence is really pattern. You should think of it as pattern evidence coming from patterns, extraction patterns like Hurst patterns, X such as Y. And the distributional evidence is evidence coming from the context in which the candidate hyponym and candidate hypernym in the NISA pair appear. The intuition being that maybe the hyponym and the hypernym, if they appear in NISA relation, then maybe they appear in similar contexts. So there is something peculiar about those contexts that you can tell for ISA pairs as opposed to other pairs of phrases. The input in this is a classification task, which takes away, I would say, a bit of the practical impact of this. You have a candidate, you must have a candidate is a pair of a hyponym or the hypernym. You don't know if this is a correct pair or not. But based on a collection of documents, Wikipedia articles in this case, what you'd like to tell is whether each of these candidate pairs is indeed an ISA relation or not. This is the outcome. For this, what they do is collect path-based evidence, which, as I revealed already, really is about how this hyponym and hypernym appear together in some document sentences, so that the sentences are indicative. As you were to read them, you could guess that these pairs of this pair of hyponym and hypernym are really an ISA pair, as opposed to not. And then separately, they collect distributional evidence. In this case, as I said, these are the contexts in which the hyponym and the hypernym appear separately in different documents, in different sentences. The intuition being that maybe if the two phrases in a pair are a hyponym and a hypernym, maybe they appear in similar contexts or something. And what they do is that they combine these two types of evidence into a single classifier so that you can tell whether a candidate pair is ISA or not. This is what the architecture or the model looks like. This looks worse than it really is. We can actually explain this. What we, how do we point here? Let's see. Here, yes. What we have here, these boxes in color, these are vectors. These are embedding vectors. 1, 2, 3 in this case. What is here is one element. You should think of this as words. These would be words that appear in a particular sentence. They appear one after the other, so together they form a path, a syntactic path, a dependency path that connects the candidate hyponym and the candidate hypernym in the same sentence. Okay? And you have different colors. this is just suggestive of the fact that, of course, these are vectors of embeddings contain multiple elements. But evidence going into each vector would capture the lemma, which is the X there, the lemma, so the word itself, noun, verb, and noun, so the part of speech tags, the dependency labels like end subj or root of the parse tree or attribute and so forth, and also the direction in the dependency path. Are you sort of like going up or down, or away or towards? So these 4 pieces of evidence, this is what is collected for each word. And then you have multiple words, multiple tokens in the path connecting, as I said, the hyponym, the candidate hyponym, and the candidate hypernym in the sentence. All these sequences, so these paths, they are fed into an LSTM, and what you end up with here is a vector of path embeddings. So you started with embeddings for individual tokens here, and by feeding them into an LSTM, you end up with the vector of path embeddings. So each of these elements is supposed to correspond to some path. This is averaged, and then there is a single layer, I think, neural network here, whose output is just a two-element vector, where one of the elements is supposed to mean this is a relation, and the other one is supposed to mean this is not an is a relation. It's easy to tell which is which by just reading off the weights at the very end. But so the contribution in this paper is actually twofold. So one is that they model all this problem through this architecture. So you have vectors of embeddings being fed through an LSTM to end up with the vector of path embeddings. And then the other contribution, as I said earlier, is combining evidence of 2 kinds. The 2 kinds are these path-based evidence, which again, these are occurrences of the same pair of phrases in individual sentences simultaneously. These are the paths connecting those phrases in the dependency parse tree. But in addition to that, you have those areas surrounded by a dotted red line. This is the distributional evidence. What those vectors are really vectors of embeddings for the hyponym, candidate hyponym in the pair, and for the candidate hypernym in the pair. And what they do is they simply concatenate those vectors to this existing vector of path embeddings, and this is how they merge the evidence. They put the evidence together. So by making available these vectors of embeddings, then the model can potentially decide, well, if I look at enough training examples, at enough pairs of phrases where we already know whether the pair is or is not an is-a relation, then we can exploit both the path evidence, so the pattern-based evidence, and the distributional evidence, how the hyponym and the hypernym appeared independently in different contexts, in sentences, in Wikipedia articles in this case, in order to decide whether the pair overall is a pair or is not. That brings us to the third kind of methods for extracting ISA data. We looked at unlabeled concepts, so extracting sets of instances that belong to the same unnamed class, and then sets of instances belong to the same named or labeled class or concept. But then another kind of work is how to organize such data into hierarchies. How do you take this flat set of ISA relations, Google search engine, Yahoo search engine, Melbourne city, and so on and so on and so on, and how you might organize all these pairs into an hierarchy? That would make sense. I listed some work here, but we'll be looking at, I think, three kinds, like three representatives for three kinds of work in this space. One is work done at ISI, at the Institute of Information Sciences. Information Sciences Institute. This is at the University of Southern California. Zornica Kozareva was a visiting researcher at the time. And she was already interested in extracting IJCAI relations from the web. She had already proposed an extension to the Hearst patterns. It's just a simple intuition that turns out to be doing remarkably better. The intuition being that instead of using a pattern like X such as Y to get IJCAI relations, it may actually be much more precise to use patterns like X such as Y and Z. And if I tell you that Google is a search engine, then intuitively you are likely to get higher precision if what you'll be looking in document sentences is sentences containing something like search engines such as Google and Y. Because that Y is likely to be part of a conjunction with, that's what you'd be hoping for. It's a conjunction with Google, so it's an instance, just like Google, and it's supposed to be a search engine. So you're just hoping, for the same kind of data, you're hoping to extract IJCAI relations, in this case, a relation between that Y and search engine. But by that time, you have verified two pieces of evidence as opposed to one. So you have not only verified in this example sentences in search engines such as Google and Y. Search engines appears, so that's one thing that you verified because you care about search engines, and that's pressed in the input. But then Google also appears, and you also verify because in the input you're also given that, by the way, I give you this seed instance for search engine. And so by checking for two pieces of evidence as opposed to one, you're just much more likely to extract something that's correct than incorrect. It's just very simple intuition, right? It will restrict the, it may affect your coverage, right? Because now you're looking for enumerations. So whenever you see something like search engines such as Google only, you may not be able to do anything with that. You want more than two items to appear in the enumeration of instances, but on the other hand, you may gain in precision. So she had already proposed that, and she obtained better results doing that. And then the next step up for her was to see how these flat set of IJCAI relations, in this case, how she could go about organizing the hierarchy, and now that it actually has better precision than we used to obtain before. The input in this would be one, what Zornica calls the root concept for the target hierarchy. This could be animals. And then one, what she calls seed concept, which is a more specific concept than the root, which could be lions in this case. So you're given animals and you're told this is the root. You're given lions and you're told this is more specific than, this is something that you want to extract for animals, and we tell you this is correct. And then your goal is to extract the entire hierarchy if you can under animals. And lions would be, you already know lions should be in there somewhere. This should be going again based on web documents and again by using some web search engine as a black box. She will use those patterns that I told you about before, these more precise patterns potentially, what they call doubly anchored patterns in the previous papers where she proposed those patterns. And again, instead of C such as I, so class such as instance, you have C such as I and J. You have two items. And she, of course, she would replace one of the elements with a star, right, with a wildcard, and that's what she's after filling in these wildcards in these double anchored patterns. The patterns consist of three items. two of them are known, and one of them is not known, and she's going after the unknowns, right, by using a search engine. So they would generate queries, get the top documents, and look inside the documents in sentences and look for matches for this kind of patterns, and then extract the candidates. And this is done iteratively. You may start with something like animals such as lion and star. And in the retrieved documents, you may have a sentence that would give you tiger as a replacement for star. And by then knowing that tiger is one kind of animal, then you can issue another query in the next iteration, which is star such as lion and tiger. So now you're looking for candidate hypernyms of lion and tiger, and maybe those hypernyms would actually be under animals. It would turn out later on, right? Because you want to create this hierarchy iteratively. And at this point, you don't really have an hierarchy, but you just want to fill in the missing edges, and then later on you'll create the hierarchy. So you create these edges, this flat set for now, and then you organize. They organize the extracted edges into an hierarchy, into a consistent hierarchy. To organize into an hierarchy, first they will just quickly and loosely decide which direction may apply given a pair of concepts in this candidate hierarchy. If you have something like chordates and vertebrates, these are two nodes, right? These are one of the sides in the many ISA pairs that they have extracted by now. Okay. Chordates and vertebrates are hypernyms or hypernyms in some of these extracted ISA relations that are supposed to be correct. And now what they want, given these relations, these edges, they want to put them all into correct hierarchy. So what they do is, again, they take all the pairs of any concepts that appear in there somewhere as nodes, and they check whether the, C such as I or I such as C, in which direction does this seem to apply. If the counts for those patterns that are indicative of these relations, if the counts are kind of skewed, biased in one direction enough, whatever that means, then they would say, okay, then this is an ISA pair, and not only is an ISA pair, but now I know which direction it is. I know that this is lower and this is high. So this is one step, right? It's not an hierarchy yet, but at least it's not random. At least now the hypernym just is under the hypernym. So now all the edges are oriented, sort of top down, and of course you have many of them. We have redundant edges, for example. They eliminate edges that can be inferred by transitivity otherwise. If you have something like lion is a mammal and mammal is an animal and lion is an animal, then you might eliminate lion as an animal. It's just redundant in the sense that it can be inferred transitively from the other two edges, from two hops. And then in another step, they retain the longest paths along edges between the root and each extracted concept. So they know what the root is. And taking each concept, which should be somewhere below in the hierarchy, they would process and filter out edges so that, like I said, they would keep, when there are multiple possible paths leading from the root to some current concept underneath, they would eliminate edges so that the longest one is retained, because that would be the more specific one. So again, in that, if you have to take the same example, animal, mammals, and lion or tiger. Of course, you'd want to eliminate that because of transitivity, but if you somehow did not, at this point you'd eliminate it again. So you would keep animal, mammal, lion, because that's the longer path, and you'd remove animal directly to lion because that's the shorter path. Like I said, this is an artificial, it's a stretch example because this would go anyway in the elimination of transitive edges. But there are more complicated examples where this would make sense. But just as an illustration, you have the root concept at the top, you have animal, and then you have these hypernyms. What you see here is what happens before you organize the hierarchy, right? You started with the root, and then you had that submission, iterative submission of queries to the search engine, where you iteratively wanted to find more hypernyms, like more of these nodes that would fall under the root animals. And you have the sort of the upper cloud with vertebrates, chordates, carnivores. These are the hypernyms. And then you have the lower cloud, which is deer and elephant and so on. These are the hyponyms. And what you have is these edges, right? The dotted lines, which are the IJCAI pairs. This is the flat set of IJCAI relations that you want to now organize into an hierarchy. And yeah, like I said, Puma in this case could have been extracted with that particular pattern, and then chordates would have been extracted with that particular pattern. They must have, because, like I said, at the top you have hypernyms. So the wild card must be in the hypernym place at the top. And at the bottom, like Puma, that's a hyponym. So the wild star must be in the hyponym place in the pattern. From here, after processing, you could end up with something like on the right side. You take all that seemingly redundant kind of candidate hierarchy, and out of that you could create just one longest path connecting animal at the top, two line at the bottom all the way. This is what this is from the paper. This graph just shows a part of the hierarchy under animals. Because they picked, for evaluation, they picked a few concepts, animals, plants, and I forgot, I think there were a few more. I don't remember exactly. And then they evaluated against WordNet. In WordNet, these concepts exist, plant and animal. They are synset somewhere, and you identify the synset manually, and those synsets in WordNet have a bunch of subconcepts underneath. So WordNet will give you, you can use the hierarchy in WordNet under those concepts, under plants and under animals, as the gold standard for this task. And then you can evaluate how your method, how their method in this case, how well it does the task of reconstructing, right? This taxonomy or portion of hierarchy already available in WordNet under plants and other animals, respectively. And they measure the precision and recall on the task, and like I said, this is an example, this is an illustration of the portion of the hierarchy that they extract under animals, which looks quite nice, I would say. Note that when it comes to precision and recall, there is a bit of discussion in the paper, but you may have guessed that already. True precision and true recall may be better than this, than the results, because these results are computed automatically relative to the WordNet hierarchy under plants and animals. But that's, even though WordNet is created by experts, it's still not perfect. Some of the edges may be missing, for example. When an edge is missing, they may get the edge, they may do perfect. They may retrieve an edge that's missing, but then, of course, relative to the gold standard WordNet, they'll be punished. The automatic evaluation would punish that edge as opposed to promoting it. But if you do a post-hoc analysis, if you just go through a few, you could go through a random set of edges that the automatic annotation evaluated as incorrect, you may find that some of them actually are correct, but they did not exist in WordNet, which is the perfect case. It's a case of text and a method being able to produce data that's not already present in a human-created resource like WordNet. What we're starting now, it's a series of 3 papers on also on the topic of extracting hierarchies. But this is a chain. You'll see, research on a historical timeline if you want. They all care about taking Wikipedia and producing an hierarchy out of it. I told you about the category network earlier on, about how all Wikipedia articles have some categories, Wikipedia categories listed at the bottom of those articles, and how those categories themselves have categories and iteratively all the way to the top of this Wikipedia category network that it's called. The edges exist, but most of them or many of them are not really ISA relations. And so the first attempt to derive a taxonomy, an hierarchy out of Wikipedia, was specifically taking as input the category network, all these edges between articles and categories or categories and categories in Wikipedia, and filtering the ones that are not ISA relations. That's what happens here. It's not that it's a small thing, but the problem is very simple. And I probably spelled it out here. Take as input the edges in the category network in Wikipedia, which are again edges between an article and a category, or a category and the parent category. And somehow, for each of them, tell ISA, not ISA, ISA, and so forth. So that in the end, you end up with a taxonomy if all of the edges that you retain are ISA as opposed to not ISA. What they do for this is that they apply a variety of filters to the initial category network. The category network is initially available, as you can think of it, as a flat set of edges. And there are a bunch of heuristics that they apply in order to iteratively, given the current set that they have not solved yet, decide that this subset is actually ISA according to the current heuristic. This subset is not ISA according to the current heuristic, and then this subset I don't know yet, so I'm going to pass it on for the next filter to take care of. As filters, besides the obvious cleanup of the categories that you have to do, because some of the categories are just internal kitchen purposes for Wikipedia, just organization, like disambiguation pages and so on. Then they apply a series of filters of heuristics in step by step, one by one. For example, they try to identify what they call refinement links. And this is very intuitive. Again, these are all intuitions, but they all make sense, I would say, even quite so. When you have a link from a category like French cuisine to a category like cuisine by nationality, you see how the head becomes the modifier or vice versa. That's a bait sign for an ISA relation. When that happens, it's probably not. When a head becomes a modifier or vice versa, that edge is probably not an ISA relation. You should not have that, right? You should have something like financial company going into company, so the head stay the same. But if the head and the modifier flip from one to the other, then this would be marked as not ISA in their case. So they are confident about it. At this stage, we have this large set of candidate edges coming in, all the edges from the category network. This step will look at those edges that are of this form, where the modifier becomes the head, or vice versa. The head becomes the modifier as you go up. And for all those edges, we're going to put them aside in the bin that says not ISA. For the rest, you move on. The next one is what they refer to as syntactic matching. So something like British computer scientists to computer scientists, where the head stays the same. Right? This is the opposite. The head stays the same. This they take as evidence that this edge indeed is an ISA relation. So they put these edges in the ISA bin. They are solved by this stage. But then if you have something like xy to zx, so again the x flip sides, modifier to head, then this is going to belong to the non-ISA bin. No, I don't know if you should go through all this in detail, but this is the intuition of a series of heuristics that all follow one could say reasonable intuitions, where each of the stages will, starting from this initial set of edges, apply the heuristics so that to decide from the current set I'm going to eliminate some as being solved, because they have decided they are either non-ISA edges or ISA edges, and for the rest I'm going to let the next filters take care of. So you have the category network cleanup, the obvious, like I said, internal Wikipedia categories. refinement links, the syntactic connectivity, so a bunch of filters. And you can see how each of the filters has its contributions. And the contribution is towards the bottom. It's going down. It's that arrow going down. Each stage has decided that some of the links coming in may be classified as either non-ISA or ISA, depending on the case. Yes, yeah. And as an order of magnitude, that's why I wrote that down. You end up with hundreds of thousands of ISA edges out of this procedure. Right? And these are categories, like I said. So if the procedure is right, now you have some sort of hierarchy or something containing 300,000, more than 300,000 edges. The same first author, in the meantime, he had, in the first paper, he was in Germany doing his PhD. Then he moved to Roma in Italy for postdoc. And he was still interested in the subject. Not only interested, but since he knew, he did the work before, he knew of the shortcomings. And yeah, I thought I actually mentioned the shortcoming. I haven't, but I can tell you what the shortcoming is. That procedure that I described to you earlier, where you apply multiple filters, not just that it sounds good on paper, of course it has some precision in code, so it will have some precision losses, but the problem is that the outcome could be not an hierarchy, but it could be a bunch of islands that are not connected. This was the biggest problem that he noticed immediately once he did that work. It was good enough, so it was published, but then he looked at it more critically, and he realized that some of the edges that you'd like to have did not exist in this hierarchy, supposedly. And that made it possible that some particular node that would be, how to describe it, that as you go up in the hierarchy from the bottom, it makes it possible that at some point you cannot advance to any other nodes from a particular node. So that means that this whole sub-hierarchy is an island. It's just, you have one sub-hierarchy rooted at, say, animal, and another one rooted at, say, car, and then there is no edge from animal upwards to anything else in this overall hierarchy, supposedly, or from car. So you don't have a whole hierarchy, but what you really have is several sub-hierarchies that may not be connected to one another. And this can relatively easily happen, actually, if you think about, after the fact, it's easy to explain everything. But higher in an hierarchy, that's where the problems start usually, intuitively. Right? What I mean by that is if you start from lion, all of us in the room can probably think of some hypernyms for lion. Lion is, I don't know, a mammal, probably easy, or maybe something even more specific. And then from mammal, how do you go up? Well, mammal, you go to animal at least. Maybe there is something even more specific, but most of us do, right? But there is a point where you go up, where it becomes a bit hard, even for people, to manually decide what the hypernym is. Right? For animal, what do you go to? Maybe something like Bing, or some people will have a better idea, but it's not quite clear. So in the upper level of this word hierarchy, let's say, it becomes trickier even for people to agree on how to generalize concepts iteratively so that they all go to, say, the same top concept, entity, or whatever it is. It becomes harder. That's even harder, by the way, to do if you extract from text directly. If you wanted to extract these relations from text directly, good luck. We talked earlier, I showed you that work by at ISI, where you organize these relations extracted from text into an hierarchy. And you start from animal and you extract the hierarchy under animal. But that's part of the story, right? If you think about it, it's a big deal, but how about extracting the hierarchy of everything in the world? No, not so easy, right? Even with that method. because when you want to extract everything in the world, everything has to be connected. And even at web scale, when you run through 5 billion documents, even you're done with those, and even then, you may not have sort of explicit enough clues as to how to connect animals to what upwards. Right? This again has to do with this knowledge that's sort of too obvious for people to express in documents. Right? You expect many documents to tell you explicitly that Google is a search engine. And maybe you expect some documents to tell you what a search engine is, right? Hyperlink and so forth. But there is a point where it's, again, even at web scale, it's not obvious that you will have enough explicit evidence, explicit. What explicit means, it's not quite clear, but clear enough evidence that something is a hyperlink. It's just less likely to happen. The higher you are in this hierarchy. Because you're getting closer to this knowledge that's supposed to be generally known, right? And therefore less likely to be expressed explicitly, because why would you write it if everyone is supposed to know? I'm not going to write that if I light the match, there's going to be fire. Right? It's the same, is the equivalent, but in is a space. Right? To close the parenthesis, that's how, this is the practical reason for the authors doing this continuing work. The fact that in the previous work coming from Wikipedia, after the filters, they had quite a few islands, sub-hierarchies that were not connected. So what they thought of then was to take that hierarchy and then look at WordNet at the same time and somehow take advantage of WordNet in order to massage the hierarchy, make it better. And the intuition here is quite easy, I'd say, to follow. If you could somehow map the nodes in your hierarchy from Wikipedia, if you could somehow map the categories into their corresponding WordNet scene sets, then you have WordNet to guide you, right? Because WordNet is an hierarchy. Once I map a category from Wikipedia, from the Wikipedia hierarchy to some WordNet scene set, I know where I am. I know what is above me. I know what's below me. So if I can somehow map this other node from Wikipedia to here, right? Then I know, yes, these two are in an easy relation in my hierarchy from Wikipedia. These two are in an easy relation in WordNet. So yes, this is correct, right? Same goes if this is flipped, right? I'm just talking about intuitions, right? The method is the method. But if my Wikipedia hierarchy tells me that this node is under this node, but then when I map them into WordNet, I see the opposite, then I know this is an error, right? I just know. So then I have to correct it, right? I know that this should actually be the opposite, so then I have to remove this and do something with it. That's what they do here. This is the intuition. So they would map the categories from Wikipedia, from the hierarchy that was already extracted into WordNet scene sets. And for this, they actually use a simple heuristic. This is not quite disambiguation. It's not full-scale disambiguation. There may be some errors in it. It's not that they really disambiguate the meaning of plants and then they actually pick the correct meaning of plants in WordNet. They do something simpler than that. Simple, but then it works everywhere. So they pick, the way they go is that they pick candidate scene sets first for a given Wikipedia category. Say for plants, they look for scene sets that contain the phrase plant, which there are several of them probably. There is the plant, the organism, and then there's probably the like the factory kind of scene set. And then out of these candidates, then they select the best one somehow. And like I said, this is done heuristically. Is not you cannot describe it correct disambiguation or reliable disambiguation, but then it works at scale. It works for all the it works for the hundreds of thousands of nodes that they have, of edges that they have in the hierarchy. So probably hundreds of thousands of nodes that they also have in that hierarchy. And once you've done the mapping, then as I was saying earlier, you know what goes into what, so instantly you'll know, you'll have either positive evidence, confirmation that one particular edge in your Wikipedia hierarchy is correct, or the opposite. You'll have disapproval of what you're thinking. You have evidence in one that the relation in your Wikipedia hierarchy is actually wrong. It's the opposite or something. Or you don't have evidence that this applies at all. And this is where the more interesting part of the work, I think, happened. What they do in these cases, this is what they do, what they call restructuring. They just adjust this Wikipedia hierarchy somehow. And by restructuring, the way they do it is in steps, but they move a whole sub-hierarchies. So one step of restructuring could mean taking from the Wikipedia hierarchy, taking plants, the category plants, and everything that's underneath and moving it somewhere else. So it's one step, but it's big impact in the sense that not only plants move, but everything that was underneath moved with it, of course. So you don't need to do 100,000 steps or anything in order to significantly improve your hierarchy. If the hierarchy is good enough, maybe you only need, I don't know, hundreds of steps or thousands or maybe fewer or whatever it is. This is just an example of how things actually work. Look for inconsistencies between, as I said, between the Wikipedia category, Wikipedia hierarchy derived from the category network, and then WordNet hierarchy. For example, in the hierarchy, you could have something like fruits, crops, edible plants, plants. But then in WordNet, you may not have anything like this. You have neither fruit crop, and you don't have fruit plant either. And then what do you do in this case? Well, so what they do is that they look for possible replacements for fruit crops. And as I said, when they do that, they cut. So fruit right now is hanging under crops in the hierarchy, in the Wikipedia hierarchy. And it's one step of restructuring, would cut that edge and change the parent of fruits. They would just pick another parent and put it there. And how they do it precisely based on one. They do it from evidence that they already have, right? Fruits is under crops, fruits is under edible plants, fruits is under plants in the Wikipedia hierarchy. These concepts, these categories may be mapped to some particular WordNet synsets, and depending on where they are mapped or not mapped, that's how they choose the reinsertion point. And they restructure the hierarchy. The fourth starter then left. He went back to Germany and became a professor, but then the people left behind in Roma became interested themselves in this topic, in starting an hierarchy out of Wikipedia. So they did follow-up work then, where the follow-up is extracting yet again a better hierarchy between among Wikipedia categories, but on top of that also extracting a hierarchy among Wikipedia articles, which is new. The previous work was already only considering categories, right? And putting edges among them and organizing them in the hierarchy. But then this one now does also create edges and hierarchy among articles, which could be much more important and useful in practice. And the reason I say that is, I'm not sure how familiar you are with the categories and articles of Wikipedia, but no, there are many articles that do not have a corresponding category. That's all I mean to say. Whenever an article in Wikipedia does not have a corresponding category, if you have an hierarchy over categories, that's not going to tell you anything about the article, because you cannot go from your hierarchy to the article. There is no way, right? You could simply, what you could do, is that you could simply just in Wikipedia look up the categories for the article, and maybe that way you connect into your hierarchy. But then for that, you'd better choose the categories that actually are ISA relations, and that's not obvious, right? Not all categories of an article are ISA, as we said. And then you still have to hope that one of the categories will actually be part of your hierarchy. So then you have the connection going up. All of this is just to say that it seems useful to get an hierarchy among articles, not just among categories. That's all I wanted to say. I mean, it was just an argument for that claim. Starting again from the category network in Wikipedia, which, as we know by now, they connect articles to categories and categories to other categories. They get an hierarchy among Wikipedia articles and another hierarchy among categories. The first hierarchy was not produced before, the first kind in previous work. The second one was. How they do it? First, they look at the text, the main text of the article in question that's been processed right now. They assume something that's reasonable, which is that the first sentence in the Wikipedia article is kind of definitional. And so the first sentence might contain the hypernym phrase for the article. The article for Mickey Mouse could start something like Mickey Mouse is a fictional character created by Disney in year something and so on. That could be the first, could be. But oftentimes Wikipedia articles are structured this way, that the first sentence or maybe the second sentence are definitional-like, in the sense that they compact, they sort of put together the very main properties that would somehow define this concept. If you never heard of this concept, these are the most important properties to first know about it, right? What is Google? If you look up in Wikipedia, it will probably Google is internet search engine created maybe, the first sentence, maybe created in Palo Alto or somewhere, Menlo Park, or in 98. So for each article, they try to find the hypernym, the candidate hypernym phrase for the article title that will correspond to the article title. This might come from the first sentence of the article. Character may be the one for Mickey Mouse. This is a phrase, right? They have a candidate hypernym, but it's a phrase. It's ambiguous. Character could be multiple things. It could be the alphabet, or it could be the fictional character. They disambiguate the hypernym phrase somehow, and we can go into details as to how or not. And then they organize these pairs of an article and a hypernym article into an hierarchy of articles, right? Because by now they have pairs of an article and an article that are supposed to be in ISA relations. And then starting from the hierarchy of articles, they are going to traverse the edges linking the articles to their categories in order to iteratively create or improve the hierarchy of articles and the hierarchy of categories. There are two hierarchies that stay separate all the time, but we can go from one to the other very easily simply through this presence of categories for an article. You can just go from an article to its categories, and from a category to the articles that are listed under it in Wikipedia. So what they would like to do is just an illustration of what they want to do. They have some Wikipedia articles on the left and some Wikipedia categories on the right. And you can think of some sort of edges, candidate edges that you might have among the articles on the left or among the categories on the right. You do have the green edges also, which are simply, again, these are the connections between articles and Wikipedia. These are given in Wikipedia. For every article, you have some categories listed at the bottom. That's all that these green edges mean. And somehow you'd like to select some edges that are ISA and remove the edges that are not ISA. This is the intuition, if you are to do this from scratch. but actually go about it in a particular way. And now we're going to a bit more details of what I've told you earlier. Right? This is the article difficulty processing, Scrooge McDuck. It's also a cartoon character. As you can see, the first sentence looks kind of definitional, right? Cartoon character tells you created when, by who, and then owned by or licensed by the Walt Disney. If you parse that sentence and you look in the dependency parse tree, then it's not going to be that difficult to select character as a potential hypernym phrase for this article, because you kind of have you kind of have X is a Y. Right? There is an equivalent of X is a Y in dependency parse space. But this is a phrase, this is a string, it's not disambiguated. You need an article. You need an article to code. The hypernym must be an article. If it's a phrase, it's nothing. So they use heuristics in order to disambiguate these hypernym phrases into some other articles that correspond to the desired sense. Is it the alphabet character or is it the fictional character? It's the fictional character, of course. And for this, they rely on links among articles in general, and common categories, and context around links. And I'll tell you more about what this means exactly. This particular article, Scrooge McDuck, may not have any link for character. In the first sentence, you have is a cartoon character. Character may or may not be hyperlinked, right? We know that in Wikipedia, often you have hyperlinks from one article to another article, right? You have a phrase that's hyperlinked and the link goes into another Wikipedia article. That's an outgoing link in Wikipedia. If character is already hyperlinked to character arts, so to the article character arts, you're done. Right? You have the phrase character and you know that it's hyperlinked, so you know what the article is. You know that Scrooge McDuck, this article, is a hyperlink of the article character arts, because Wikipedia already tells you so to the hyperlink. If you're not that lucky, so if character in that sentence is not hyperlinked, in fact, in Wikipedia, instead of giving up, you can just try a bit more at least. And how can you try a bit more? Well, what you can do is, for example, look at the categories of Scrooge McDuck in Wikipedia. We don't see them in this slide, right? But at the bottom, it has some categories. Look at so take each category and then go down, look at all the articles under them. Scrooge McDuck is going to be one of them, but then there are other articles that are sort of siblings of Scrooge McDuck. And look inside those articles. Do they happen to contain character? And if so, does it happen to be hyperlinked? If it happens to be hyperlinked, you steal the evidence from there. Because you're hoping that given a category, you're assuming or hoping that all the articles linked to a category are going to be consistent in word senses, right? It's an assumption, but it's going to be a reasonable one, often, right? If I'm anywhere in the hierarchy here somewhere in the Wikipedia category network, I'm looking at this category and I have these articles that are linked directly to it. It's very reasonable to assume that any phrase mentioned in the article is going to be mentioned with the same sense in all these articles. It's not guaranteed at all, but it's a reasonable assumption, or at least it's reasonable to assume that there is a majority sense, right? If this is about, if this category is about entertainment, about movies, then the occurrence of character is likely to be about character in a movie, or like fictional character or character arts, as it's called in Wikipedia, as opposed to the alphabet character. Right? But if you are somewhere like German language or somewhere, or language or something, character there may have a different sense. Right? And if it does have a different sense from one of the articles, for one of them, then it's possible or likely that other articles linked up the same category also have that other sense of character as in the alphabet, or as in language, as opposed to as in entertainment. So through this kind of heuristics, it's not like everything is lost. It's not like all is lost. Even if you cannot tell easily what the hypernym phrase has as a meaning, what the sense is from the current article, you can still look around it, so to speak, in the category network, and you can still guess reasonably. Once you've done this, you have pairs like Scrooge McDuck going into character arts. This is one pair, is a pair between two articles. And then you'll have some Wikipedia articles on the left in your potential Wikipedia article hierarchy. And then you'll have some categories on the right in your potential Wikipedia category hierarchy. And now you want to create this iteratively. You already know that these categories on the right are listed under that category on above, right? This is just information in Wikipedia. The category at the top is just a parent category of those categories lower down on the right. Yes. Then you also have the green edges, which is again information available in Wikipedia, which only represents the fact that in Wikipedia some articles like Real Madrid FC are listed under some categories like football clubs in Madrid in Wikipedia. This is given again in Wikipedia. Given the fact that football clubs in Madrid on the right is connected to Real Madrid FC, it's just the parent category of the article on the left. And then given the fact that at the top, football teams on the right, the category is connected in Wikipedia to football team, the article on the left. The fact that on the right side, one of the categories is under the other suggests that on the left side, you should also have the same, that the article at the bottom should be under the article at the top. And so this is evidence that on the left, the link between Real Madrid FC and the football team is an easy link, because it should reflect what happens on the category side. Any questions on that one? Then moving on, you have the fact that football team is connected to football teams. I mean, this is already, it's just in Wikipedia at the top. You already know that. The article at the top, at the left, on the left is connected to the category on the right. What that means is that between on the right side, you might have an easy relation also. It's not just an unnamed relation between football clubs in Madrid and football teams, but now you think it's an easy relation because again, it should reflect what we have on the left. Moving on, Atletico Madrid was already listed as an article under football clubs in Madrid. And then, so at the bottom, we already had this in Wikipedia. This article is under this category. This article is under this category in Wikipedia too. This is just not from Wikipedia. But by now, we have decided that this category is under this category as an ISA. Then on the left, we're going to infer that this article is an ISA, this article, iteratively. So iteratively, you make decisions on either side based on what you know so far on the other side. And so iteratively, the hierarchy for the articles in the hierarchy for the categories can be built. After you do this, you will still have some more work to do. For example, some nodes may not be connected. There may be missing links going down and going up. This is an obvious expected outcome of the procedure. You may have something like this. You have comic characters by protagonist. which is a category in this category network that you have created so far, but then it has no parent, see? It's somehow disconnected. If you go back and you look at the category network, so you look at the raw Wikipedia data, then you only see one parent category for it in Wikipedia. According to this one heuristic that they use, in this case, you have some category with no parent in the hierarchy. If that category has only one category in the Wikipedia category network, then you just assume that that edge is going to be an IJCAI edge, so you're going to connect them. It's a heuristic, right? So this may fail. It actually does fail sometimes, but it's an heuristic. It's one way to fill in some missing edges. This is the more interesting heuristic, again, for inferring, for filling in missing edges. This is what you have. You have comic characters by company, which is you're interested in. You have these subcategories at the bottom. And then you have these existing edges already in the hierarchy. But then for comic characters by company, as you see, you don't know how to go up or where to go up at all. So this is the current state. On the left, you see that you have two IJCAI edges going up from the children of comic characters. You have this red box at the bottom, right? These are the children of comic characters by company. According to those children, you can go to comic characters more so than you can go to comic titles by company. Right? For that reason, you'll be hoping and you'll be inferring or guessing that you can go from comic characters by company to comic characters. Okay. This happens because it's not represented here in this image, but you already, in the category network, comics character by company already had comic characters as a parent. But you did not know if it was IJCAI or not, of course. But this way, this is how they decide that this is in fact an IJCAI edge, and they actually assert that IJCAI edge. They could not do it before in the previous steps, but now they do it, and the way they do it, as I said, is based on evidence coming from the children. More children vote for comic characters, and so that one is chosen as being the parent for comic characters by company. As for the role of all these resources of IJCAI relation information retrieval, this is a game that's still being played. This is how I would summarize my findings and my opinion about it. More generally, one could argue that for information extraction, it's still a game being played when it comes to showing or demonstrating the utility of these extracted information or extracted relations in information retrieval. That's also the case for IJCAI relations. What's already happening? Matching something may be happening when it comes to matching queries and documents, but this is more like academic findings, which should have questionable value in practice, probably. And then what does happen is some sort of one-box search results, some sort of special results that the search engines would show in addition to the rank list of web documents that are supposed to directly answer some information that the search engine is guessing that you actually had in mind when you submitted the query. And IJCAI relations can and do come in handy sometimes there. But let's look at matching of queries and documents. Early on, Ellen Voorhees had this study of how information expansion could benefit from lexicosemantic relations, as she was referring to them. WordNet, the idea is that WordNet existed by then. It became better known, and the question was obviously, okay, then we have WordNet, it covers quite a bit of English concepts. Then we have information retrieval, probably WordNet, something like WordNet should help with information retrieval, right? Because if someone looks for, say, animals in California, as the query, arguably they would also be interested in mammals in California. And mammal is a hyponym on animals, so WordNet or an hierarchy of concepts might help in such cases. So that's what she did in that study. She just investigated the impact that such resources like WordNet could have on information retrieval, on the quality of the retrieved documents. And for this was early on, right, remember? And for this, luckily, one could say, she did two things. The author did two things. One is what you sort of expect someone to do, which is check if there is an automatic method that you can come up with that you could show that would be beneficial for information retrieval by exploiting WordNet data. But then she also did a manual analysis. So she also had experiments where manually, given a query, manually she would pick the correct sense from WordNet, given that particular query, and then check whether that automatically, given the evaluation set, check whether that would have better or worse accuracy for IR according to the eval set. And the findings were not that promising in the end. They were that if you do this manually, if you identify the concepts manually, this seems to improve things based on that eval set back then. But if you let the computer do it, at least back then again, this was not beneficial for the task. So the manual, I'm not sure if this is clear because I don't think I specified what we mean by manual or systematic. This is think of this as word sense ambiguation. The queries are phrases, of course, they are n-grams, they are words put together, but WordNet is organized around synsets, around word senses. The same word from a query may appear in multiple synsets in WordNet. If you have plants in California, then it's probably better if you realize that plants here is in the sense of an organism as opposed to factory, and then not go in WordNet and expand under the factory sense of plants, because that will probably give you worse results. So if you do automatic expansion, you either have to do word sense ambiguation somehow. So in this query, you have to understand that plants has the sense of not a factory, but of organism, and then automatically choose the hyponyms from there. Or you don't even try to do word sense ambiguation, and then you pick hyponyms from all the possible senses, and then expand that way. This is what you could do automatically. Manually, you could, if you do it manually, then you point to the correct sense, and then the method will automatically pick all the hyponyms underneath. If you can't point to the correct sense, there is a bit of improvement in that on that eval set. If you let the algorithm do it, if you don't do a perfect word sense ambiguation, then this actually has worse results. And this is not very promising. It's not because, if you think of it, many queries would not necessarily, how should I put it? In order to improve the quality of an IR system, web search, whatever it is, when you do query expansion, it's not obvious that ISA relations would be the main kind of relation that you'd need for this sort of expansion. It's not obvious at all. It's possible that what you want is some sort of related, topically related phrases or concepts that are not necessarily ISA. If you look, say, for, let's say, flight to Melbourne, if that's the query, then it's possible that the results would be better if somehow you enrich the query with something like airfare. This is just an assumption. I'm just thinking, sort of thinking aloud. But it's not obvious that you want to go from flight to some sort of hypernym or hypernym, or from Melbourne to some sort of hypernym or hypernym. It's possible that query expansion, automatic query expansion, would benefit from at least some other kinds of relation types besides is-a relations, and maybe even benefit more from those than from is-a relations. So if from is-a relations, in this sort of control setting, if you cannot get much improvement, even in the manual setting, it doesn't do that convincingly well. This doesn't bode well, right? For how is-a relations would be used to automatically expand queries in IR. There was a question, I think.
I'm not sure if I got the question. I guess, yes, that also depends on how the underlying search engine do the search. But suppose the search engine does not handle well the hierarchy, for example, when you search for animal, if the search engine already could deal with horses, cows, cats, and dogs, then doing expansion might not have that much. But if the search engine does not do this well, then I think it helps. It's kind of a difficult thing to see because the search engine is kind of a black box for users.
Oh, right. Yeah, of course. But this can be, yeah, we're moving. I think we are connecting two very different scenarios in a way. Yeah, probably it's not that wise. Because you'd have the clean scenario where you have an information retrieval system that it's not a block box, it's an open box. I mean, you know how it works. It's not like you don't have to go with the tools and adjust anything, but you know what it's supposed to do and know how it's supposed to do it. And then you have in the other scenario, you have the search engine that's a black box, right? There is magic in it that you don't have access to. But it doesn't change the argument or the conclusion or the intuition at all. Because like you said, if the search engine somehow can go from animals to horses and so on, then you don't need this. Yeah, but does it? And if it does, how, right? How does it do it? It's like a chicken and egg problem, right? In the first place, it has to know to go to horses. And not only that, but this has to be beneficial in a large majority of cases, opposed to not beneficial. So the impact of doing this expansion, of course, will depend on what the IR system already does. If it already has access to such information or similar information, then of course it's not going to add much on top of it. That's to be expected. There was someone else who was bold enough to try to revisit this sort of experiments. Again, using Warnet to see if actually there is a way to make query expansion work for IR. And well, again, the outcome was not quite really, to summarize. But there are some things that work to some extent with these relations. When you submit a query like French presidents to big search engines, to the bigger ones, you might see a result like this coming up. This would be at the top of the other regular results, the rank list of documents. You may see something like France presidents, and you see a few presidents maybe ranked in chronological order, inverse chronological order. What goes behind the scenes, again, as users, you cannot really tell, right? Exactly what you said. This is a black box, right? If you were to look at it, it's as if, given a concept like a hypernym, you're getting hypernyms for it, or instances for it, right? All these individual people are indeed instances of French presidents. It's possible that under the scene, something a bit different is going on, not just ISA relations and access to ISA relations, but something a bit more than that, right? And the fact that what you see above the images is France presidents is a clue that maybe it's not just ISA relations that help to do this, but there is more structured information, structured data there that is at play. That is at play, right? France presidents. In question answering, which has steadily evolved over time, becoming, getting more and more impact in web search. When you submit a query like what animals live on the coast of California, again, you may have a one-box result, one sort of special result at the top of the other documents returned, which could look like this. It's like a special snippet at the top. And you see how some of the phrases, some of the n-grams are in bold. They are highlighted there. Right? Plausibly, these are somehow detected as some sort of instances that would answer this question, right? So plausibly, these are some instances of animals in this case, because that's the answer type word, as they call it in, or answer type term, as they call it in question answering literature. There is a large body of work in question answering, and part of question processing, a key information that comes out of the question is what they refer to as answer type word or answer type term or something like that, answer type phrase, which would be something like animals in this case. What animals live on the coast of California? The intuition being that your answers, whatever they are that you extract from documents, should be so that they are instances of this answer type term or word, animals, and they have to satisfy somehow the rest of the question as well. So a lot of question answering systems in practice do question answering, open domain question answering this way. They find candidates that belong to sort of the correct type, where the type is animals in this case, the correct class, the correct hypernym, as we were saying today in this tutorial. And then, of course, somehow the system must somehow ensure approximately that the remainder of the question, live on the coast of California, that's also somehow satisfied by the longer answer. What marine animals live on the coast of California? Again, this is a least-seeking question, so there are multiple answers probably that you want to extract, and they exist, and hopefully the search engine will be able to somehow give them to you. Currently, at least some of the search engines try to do it this way again. There is a special result at the top where some candidates are highlighted, hoping that that might be helping you get in faster to the answer of this question. You should, yes, and then answering regular questions as opposed to least-seeking questions, something like which US president attended Harvard. And again, special snippet at the top that will hopefully contain the answer with some of the portions in the snippet highlighted. This is not the topic for today, but when it comes to web search and impact of anything that we would do in information extraction or in anywhere else in web search, in improving web search, at least some of the problem is non-technical in a way. We think a lot about how do we make question answering better and how do we get the correct answer, and then wait, but then we already had documents that were returned, so the answer was already maybe in the first document, but then, oh well, hey, but then we can do better than that. Why should the person read the whole document? Can't we extract the answer from there? Yes. What does that mean? Well, maybe we can extract a snippet around the answer. Maybe, no, you should extract the correct answer, the correct phrase. Well, yes, but if I extract the correct phrase, if I mess up, if I show that on the on the homepage of one of the larger search engines that has a lot of popularity and a lot of attention from the media and everywhere, that could raise questions as to why have you extracted this answer incorrectly and so forth. And so there is a technology how you could do question answering better and better and better. And there is the non-technical aspect of how do you present this information. If you were to show something like a list, Barack Obama, George W. Bush, and Franklin Roosevelt, if that's all that would be very bold. That would be true question answering, you could say. Yes, I applaud you because you're doing the job. I asked you for a list of presidents, and that's what you're giving me. But if the search engine did that, it would open itself to a a barrage of criticism because of all these possible mistakes that it can and will do in trying to answer questions. And so to avoid that, right, to avoid confusing people, it's not just a matter of public relations. It's not just that, it's confusing people too. Because now you show Barack Obama and then they ask the question a bit differently and then they don't show Barack Obama. Or you show the incorrect answer and they may believe it's a correct answer and then they check, oh, then I'm not going to believe this search engine anymore. I'm not going to ask questions anymore. This is a choice that is non-technical. It's how we present these answers, right? We can either be bold. So internally inside the search engine, it may be that there is a module at the very end that has ranked the candidate answers, the 1,200 candidate answers. And the module may be so good that it has ranked them well and it has decided you should stop after 12. And that could be the correct one. This would be the ideal scenario. It only happens 1 in a million cases, but it could happen, right? But even if it does happen, that doesn't mean that the search engine should be bold, so bold as to showing these answers this way. It may be much safer to show a bigger snippet like here, and then to help the users, you would maybe highlight what you think are the answers, but not do much more than that, right? In other words, the search engine here does not shout in your face, I know the answer. It could do that by just showing Obama, Adams, and so on, by showing you only the correct answer, so to speak. But that's shouting in your face, bragging, and then you'll take it at face value, and then you'll be upset or surprised, or you'll be laughing the next time the search engine makes an error. This is the safer way to go, of course, right? It doesn't quite extract only the answer, but it does more than just giving you a document and the link to the document. It finds a snippet that's probably relevant to the question, and it even highlights some piece of information. And if it were to be wrong somewhere there, you'll not be as upset or as surprised, and so forth, probably. I just wanted to mention one, yeah, we're just on time. One area that I think will both require and it must receive more attention in the future from now on when it comes to user relations. So Marty Hurst created those patterns. She proposed those patterns in 1992. And we've been using since then. We came up, of course, with many other much more interesting methods maybe, or other sources of evidence towards extracting user relations. But when you look at everything we've done so far in our research, people's research, I only showed other people's research here. I've looked at this area a bit myself. But we all have some very, very pink glasses that we put on and only allow us, or we chose to see just one part of this bigger crown. When we have a relation like aquatic mammals going to mammals, this then is a relation, right, obviously. And all those hierarchies that we saw, the hierarchy under animal that the researchers from IJCAI extracted with lion underneath and everything, it was edges connecting lion to mammal to animal and so forth, and that's correct as an hierarchy, right? But something is missing, right? What those edges tell you is that, yes, mammal is an animal. Yes, aquatic mammal is a mammal. That's what it tells you. It's a big deal, right? These are not, it's a big deal because now aquatic mammal is not just some unknown point in the space, in the semantic space of everything in the world, but it belongs here under mammal. But it's not enough because mammal hints at the genus of this concept, but then aquatic hints at the differential. And we just don't do the differential at all. We have all these references that I listed here, and you'll find your own favorite references. Some people here in the room who work on this subject, who are experts, they would know many more references that I presented here, that I may not even, I haven't listed everything I know, and then there are things that I just don't know that I missed, and you would know. But everywhere, I haven't seen everywhere, that we've done anything about the differentia. This made sense for a while, because getting this sort of hierarchies in the first place is not obvious, as you've seen, right? There is a chain of work on getting a hierarchy from Wikipedia. It takes a while, right? And it's not perfect yet, maybe. Maybe a bit more work has to be done there. It took some time to get out, to start from easy relations extracted from text and organize them into an hierarchy, like that paper from ISI with animal and lion. But then as these things advance and move on and we get better hierarchies, there will be time, or it is time maybe, to understand how a sub-concept is different from a super-concept. Because what we know now is how they are similar somehow, right? We know that one is under the other, right? But being under the other, that means, like I said in the very beginning, I think in the very first slide, it all goes into a circle in my mind, because I care about this topic. That means that the sub-concept probably inherits the properties of the super-concept, which is useful to know, right? If I know that aquatic mammals is mammals, if I don't know what aquatic means, at least I can assume that it's everything that a mammal is, or most of what mammals is, and something else. But the something else we don't really try to look for. Right? And these are IJCAI relations. The IJCAI relations really encode the genus in the sense that the hypernym is the genus of the hyponym. Right? The hyponym consists of a genus and the differentia. The genus is what the hypernym brings. It's everything that's inherited from the hypernym. But there is some differentia. There is something added that makes this a new concept, right? Aquatic mammals is not mammals. It's underneath, so it brings something new. And what the new something is in this case is whatever aquatic suggests. And we know what it suggests. If we know English well enough, or even if we don't know, we look it up, and it's water. So this is mammals that live in water, probably, right? That's the property. This subconcept brings something new. It's a mammal with the added constraint, live in water, or something like that. I think we'll be seeing more and more work, or a little bit of work and then more work on this. I expect this to happen in the, I don't know, future or near future, because it's the obvious part that's missing. The topic is very important, and I guess it was difficult enough, or it's not that if we solved it. It's not like we know to extract hierarchies, and it's not like we can reliably extract even these individual edges. Forget about an hierarchy, just pairs of IJCAI relations, right? There may still be noise in there. But if you want to fully exploit what's already in one individual pair, one individual IJCAI relation, we should probably try to see what exactly the sub-concept adds in addition to the super-concept. Because oftentimes that information is it's implicit, but it can be glanced at least by humans, right? When we read aquatic mammals, again, we know what aquatic means. It doesn't say mammals living in water, although that might be a paraphrase. That could be a synonym. It might be. But aquatic, that modifier encodes some relevant property that is added to the super-concept and creating this sub-concept. And we'll probably see, I expect or I hope, more work trying to find what sub-concepts add to the super-concepts. It would all make sense, it would all be relevant, it would all be useful, because again, as I said in the very beginning, a concept is what? Is a set of instances that share common properties. If there is a sub-concept that's worth adding under mammals, there must be some set of instances that belong to that one, which must be a subset of the bigger one of mammals, right? And so it's a smaller subset. It's aquatic mammals, a smaller subset than mammals. Smaller why? How? Well, it's smaller because they also satisfy this added property of living in water in this case. A father is a parent. Why? It is a parent, yes, that's the genus, but what's the differential? The differential is that, well, the gender is male, probably. A sports car is a car, right? A city is a location. Why? Well, it's a location, but it also has these properties, added properties, and all the instances have to satisfy them. So the set of all cities in the world is a subset of all the locations in the world. And we can already tell that, but we don't know why. And the why could be in there. Or if it's not in there, we should probably go after it. This was just an illustration of, just to make it obvious that you can specialize in different ways. Obviously, all of these are subconcepts of mammals or hyponyms. And as you can see, they are obviously subconcepts or hyponyms for different reasons. Aquatic mammals is a hyponym for a different reason than African mammals is. Because what changes is something else. One is living in water and the other one is from Africa or something, or living in Africa. If you have any questions, I think we have a bit of time if you'd like to go through them, but this would be the end of the tutorial. Yeah, thanks for lasting through the end of it.
Formal concept analysis, which proposed very nice and useful modeling conceptual hierarchies. In fact, constructing them from data as well as archive data, like text. Thousands of papers, conceptual hierarchies, which are built from formal concepts.
What's a formal concept?
What relates your research to the study in formal concept analysis?
What's a formal concept?
There is an exact mathematical definition. It's a pair extension and intention, which is a classical understanding of concept. In your work, you use rather intention.
But this is not, yeah. I just presented everyone's work. Yeah. None of this is my work. I just gave an overview of what other people have done in the area. One could relate, but if it's just... But how would that apply in practice? Because I haven't... I don't know of anything like that. Yeah. I haven't run into it when it comes to extracting from
extracting hierarchies, merging hierarchies, intelligence, complex collections.
Yeah, I just missed them all. Yeah, maybe you'll give me some citation. But you'd expect such work to show up in sort of the larger conferences. It's something like ACL or World Wide Web or IJCAI and so forth. And you'd expect those authors to be sort of like known in the community too. What would be some groups in that space? Like research groups? Yeah, I don't know. Yeah, I don't know these people. Is this mainstream? Because I don't, yeah. I never heard of these names too. What? Yeah, okay. I'll look it up, yeah. I never heard, I would have expected to. I'm supposed to know about this stuff. And if I don't, I should correct that, yeah. Because I'm supposed, yeah, especially I expect myself to know about word that would also have some potential, like potential in practice. Be able to go after, I don't know, a large repository of web documents and be able to extract from it and do something with it afterwards. And I haven't, yeah, I haven't heard of this. Yes?
My understanding is most of the relation with applicant and all this is a relation. So it's like a logical relation. So could we do richer structure with other types of logical relations?
This is subsumption. When you mean logical relation, this would be this is subsumption, right? Yeah. One concept is the more specific concept is subsumed by the more general concept. There is one. There are many relation types, so that would be switching from extracting IJCAI relations to extracting relations of any kind, like an open domain information extraction, where you go after many. You will go after actors acting in movies, and you go after cities being located in countries and so on. So the type could be, the predicates could be of different types. But that's something that I'm not sure if that's what you're thinking about. But no.
Ways that I guess semantically, conceptually, different things.
There is one way that. There is one way that one other way that can fit concepts under other concepts, but that is not IJCAI. And that could be Wikipedia, in fact. The Wikipedia category network, when you look at it, illustrates exactly this phenomenon most of the time. When an edge in the Wikipedia category network is not an IJCAI edge, most of the times it's like what I'm saying now, and it's some sort of a topical, like topically broader. I don't know how to refer to it. You could have something like Paris under France. I might ask you for some of the citations. I'm really curious what I missed. It's so big. Something like movie could be located under entertainment in the category network. And it's not an IJCAI relation, right? Movie is not IJCAI entertainment. But then somehow you could think of the bigger topics sort of capturing the smaller topic. Or when you go from something like Paris to France, which may happen in the category network too, in Wikipedia, again, you could think that in a way you're going up, right? It's not IJCAI, but you're broadening. You're not going up, but you're broadening in that sense. You're going from something more specific to something more general, but it's not IJCAI. Paris, France, and so forth. Then you may go from a book to the author, or the other way around, which is why actually this is messy. This is much messier, in my opinion. This is like broadening, sort of, I don't know what to call it, broadening relation or whatever it is. This is messy because broadening is like related, and related means nothing in the end, means everything and nothing, because everything can be related to something. Everything can be related to everything in the end, and you don't know what's, it has to be strong related, but what does that mean? And then even the direction is not clear. Should the book be under the author, or should the author be under the book? Probably the first, but like, who knows? You know, sometimes it's a now known author, except for that one famous book, and then maybe the author is under the book. But I don't know if this is what you were thinking of either. But there are ways to organize the world to make it into compartments or into smaller bins, where as you move from the bigger to the smaller bin is not necessarily through an IJCAI specialization, I think. And you know, in information retrieval, this might be useful too, who knows? It's very hard to put a finger on it, because it's very hard to define, like I said. Broadening means related. When you say related, you should, that's like red flashing light. Because that, wait, stop. What does that mean? Right? What does that mean? Can you define it? It may be very difficult or even impossible. What is related? What do you mean related? An ant is related to a butterfly somehow. So, but still, despite the difficulty of defining the task, there is some common intuition, right? As I said, this is not like I saw many big eyes in the room. So there is some common understanding of this, and probably there is some implicit acceptance in the audience that, yes, there is some other way to organize the world, and it's not easier. It's like broadening somehow. How, we don't know, but it's plausible. I'm not sure how to do that. It's also not logic at all, by the way. You'd lose the logical aspect in it. In IJCAI, at least it's subsumption, so it's supposed to be transitive, for example, right? Because it's subsumption. You're supposed to go from the bottom all the way up, and it's all transitive. You can keep on going. If it's broadening, in a way you can keep on going because, you know, it's related somehow, but at the same time, you go from ant to butterfly, and then from butterfly to antenna, and from antenna to something else. It just doesn't, they are so loosely related that it doesn't make sense anymore. Yes, sorry, there was another.
So regarding your last point, so is it like, so I mean, in the story, so large thing is, you feel this is what will be lacking in the previous research. Okay? So did you, so just trying to summarize your article, you know, in case I'm not misunderstanding that, did you trying to say that before we just focusing on the surface level, and we might expect something meaningful, but we just don't know how to explain it, like why they're having such a structure, and how they're different, and why some entity will be the parent or other entities.
It's not what I meant. No, I meant something more specific than that. Not only more specific, but also different. I meant that regardless of the method and the sources of evidence, what we end up with now is pairs of IJCAI relations. They could be organized in hierarchy or not. I don't care. It doesn't matter. That's irrelevant to what we are talking about now. It's pairs of a hyponym and a hypernym, more specific and more general. That's a big deal because it allows us to know what the hyponym is, right? If somehow you didn't know what the hyponym meant, there is a time when you first run into a new concept. Either because you're a child, so you learn the language, you learn it for the first time, or you're grown up, but there is some domain that you don't know very well, and boom, you just run into this thing for the first time. And then you don't know what is this. It's one of these things. Okay, then you've cleared up your head a lot. So now you know a lot about this, right? This is like a car, right? Bongo Bling, I don't know. What is it? It's a car. Okay, I know a lot about cars. So it's not a dog, it's not a ceiling, it's a car. And then you have to know more about what car it is. But in these relations, all these assertions are, this is a this. So this inherits all the properties from here, probably. The genus of this hyponym is this hypernym, but we don't know how the hyponym differs from the hypernym. They must differ, because otherwise they'll be the same. They would not be separate, right? Why do you have car and sports car? You have sports car because sports car is different than car. Otherwise, they would not talk about sports cars. So sports cars are cars that are what? What else? The what else, we don't do the what else at all. No one does the what else. So all we're trying to do is to get sports cars are cars, cars are vehicles, vehicles are transportation means, and so forth, which is a big deal, right? To do this ideally over the whole universe, so to have this giant hierarchy if we could. But in these links, there is a reason why you hop down in these links. You specialize. How? And this becomes more visible if you see like something like this. It's just, right? If you forget, this will remind you, right? Because you go from vehicle to car. Okay, so maybe you don't think about this. But if you go from vehicle to car, and from vehicle to bicycle, and from vehicle to motorcycle, right? What you may have glanced over and not realized, now it's in your face. So now it slaps you in the face because now it's clear. You have all these sub-concepts of vehicle, but they are different. And they are different because they specialize maybe vehicle in different dimensions, right? Bicycle is like 2 wheels, motorcycle, same thing. Car may be multiple wheels, and then you have motor car that has a motor as opposed to being pushed or something. In WordNet we are, right? Many of us know about WordNet and maybe look through it. And oftentimes if you look under, say, person or, I think person. If you look at the hyponyms of person, the immediate hyponyms, then I think you see something like man, woman, among the hyponyms, and maybe others. These are all siblings, supposedly, so they are at the same level, immediately under person. But then man, woman, they are hyponyms because of what? Because the gender, right? Not only that, right? But then these two form a partition. We don't know that. That's stupid. It's idiotic, right? I mean, I'm not saying stupid. I understand it's difficult, but you want to know that, you want to understand that when you have man, woman, and then you have, I don't know, stupid person and intelligent person, which I'm just inventing, and so many, right? You have to know multiple things. One is that man and woman mean that the gender is whatever, that's the restriction. Stupid and intelligent person mean that, I don't know, the intelligence coefficient is the low or high. And then you also want to know that man and woman form a partition of the world, right? These two, if you take like all the people in the world, they are all like sort of man or woman. And then you're done with them all. And then that's one dimension, and then stupidity versus intelligence is another dimension. And then professions, doctors and lawyers and so on, is another dimension. And they're all different dimensions, and they all form their different partitions maybe over the world, right? Man and woman, this is one partition of everything in the world. And then doctors and lawyers, hopefully not everyone, but all the professions together will form a partition of the whole world. All the people, any person here, you can put them in one of the bins, I mean, from here, and that's it. And then move on. Another set of bins. We don't know all any of this.
Given hierarchy structure, you're trying to see what's the like person to men and women, scientists and teacher.
It's
trying to get the attribute.
Yeah, you can think of it that way. Yeah, some attributes, some properties, some hidden, something. Yeah. A lot of times it will be like attribute value pairs, but not always maybe. If it's man, it's like an attribute value. It's attribute gender, value, male, right?
Yeah.
If it's women.
Also have male scientists. That's a group of people.
Which one?
Male scientists. So it's a specific like gender and occupation.
Yeah.
Together.
So yeah, but that makes sense.
Right.
Yeah. But think about it. This is actually not. Yeah, it has high generative power, right? So I don't know how exactly that would work. But then it's not useless on the contrary, right? Think about it. You cannot have male-female actors. Why is that? Because you have different values for the same attribute. You have conflicting values for the same attribute. You do not have American-French companies. There is a stretch, right? That could mean actually, it could mean something, but let's ignore that. Right? In principle, you cannot, because a company would either like headquartered in America or headquartered in France. You cannot have both. You cannot have stupid, intelligent person, at least according to the strict sense of the word. You cannot. One person cannot be like high IQ and low IQ. You cannot have two-wheel, four-wheel drive car. So some of the incompatibilities, some of these like restrictions that cannot go together, they don't go together because of this, because they are probably same attribute and conflicting values. Intuitively, that's why they don't go together. That's why you don't see them. Yeah, so it's good despite all this work in ISA relations. There is at least, I think, one area that was not explored at all in practice. It is. So but if you're curious about this, where you want to look is we can start from work on analyzing compositional noun phrases. Compositional noun phrases. It's like aquatic mammals versus mammals. Not versus, sorry, aquatic mammals. Aquatic mammals in English is a compositional noun phrase. It's a compound noun phrase whose meaning, overall meaning intuitively, is like the sum of the meanings of the constituents. Aquatic mammals is the meaning of mammals, sort of plus the meaning of aquatic, which is living as opposed to hot dog. Hot dog is not the meaning of hot and the meaning of dog. That's non-compositional. But many, and so that's a place to start. And the reason is that when you do ISA extraction at scale, like from the web, not just there, but even look in Wikipedia. I don't have to make arguments for this. Like the web, it's not that we need the web to prove this. In Wikipedia, many of the categories that are true concepts, so not like Google and France, because those are categories too, but like French painters and search engines and financial companies and so on. A lot of those categories in practice are compositional noun phrases. There are relatively few of the hot dog kind of classes, and many more frequent of the financial companies classes, the compositional thing. You add, you restrict the super concept, you restrict it more and more. And this is natural because you start from the top, you start from entity, right? You have organism, you have person, and then you have, I don't know, you have doctor, and then you have surgeon. And then there is a point where in language we have not yet invented another word for the sub-concept. But what we do, we may still add modifiers. So we hit surgeon, and then we may have like brain surgeon. We have not invented brain yet. Like brain surgeon is a one word. I'm just inventing this word, right? But if that turns out to be relatively frequent or somehow, many people in that area talk about this a lot, maybe in some number of decades that word will exist somewhere like that, right? Because it happened before, actually. Laptop would have been computer to be carried around. And then you say that 75 times, you get bored, and then you want to come up with a short version, and then maybe you invent laptop. I'm just saying. But so towards the bottom of any hierarchy, that's what I'm saying. Towards the bottom, before you hit the instances, you are still in the concept space. At the bottom, you'll see many of these modified concepts, probably, in a fine-grained taxonomy. And you want to know what they mean. You want to know what does brain surgeon mean. It means surgeon that operates on the brain, or something like that. And we know that. Right? Yeah, in the NLP community, there is interest. For a few years now, in analysis of compositional noun phrases. And I care about that because of this, because to me it connects to ISA relations. Because in practice, in a lot of ISA relations, the hypernyms in practice are fine-grained noun phrases that are compositional. Not a rule, but for every hot dog, you have like a million financial company, Australian citizens, so on, truly compositional noun phrases. And now that's all we do. We say Melbourne is an Australian city, but we don't know what Australian city is. Like a stream, Australian city. But that means city located in Australia.
Would you share this?
Yeah, if you send me Yeah, an email I'll send them. The email I had it in the first. Well, I guess you can find the, yeah, you can probably find the email, or should I show you the email? Okay, it's the first.
This is really comprehensive.
Well, but then I may have missed. Yes, yeah. Some of the work I did listed on purpose because I meant to give a percentage. I'm not going to list everything on the slide. The only slides and slides are just references. And then I don't know if I missed some big body of work like the other person was suggesting. I was not aware that that has been a practical body of work. I have no idea. Just let me surprise.
That's a pretty old concept.
But I don't see it using practice. I'm not seeing it, so I would easily miss old or new concepts, but I never saw it in any published approach that would go after extracting these relations, like scale in a way that is mathematical. I don't even know how exactly to start. Maybe I started in the chief phase. That's my favorite for researching. In current like recent work, no one ever spent time talking about how mathematical representation of concepts should possibly operate in practice. People from the Max Planck Institute and people from the University of Washington doing, people from CMU with an system doing, Simone Conceptual has this database of these relations extracted from the web documents and available online. He's in Germany. If he doesn't, I don't know what that's. I don't know if that means anything. I'll check, yeah.